This conference will now be recorded.
Hello, good morning, guys.
Good morning, Shiva.
Hey, good morning.
Good morning, Shiva.
Very good morning, guys.
Hi, good morning, Shiva.
Good morning, Shiva.
Good morning. Very good morning, guys. Let me
Good morning,
bring up. Good morning. Is there anyone who haven't joined the demo? And do you have any questions? Anyone has any questions, guys? Okay, so let's get started, guys. If no questions, we'll start it. We'll get started. So before we talk about any of the AWS services, I believe it is important to understand few concepts of you know the data center, like what is a data center, what is that we have, why do we have these data centers, right? We should know about the infrastructure, and then we will look into the AWS infrastructure, guys. Okay, so could someone tell me what is the infrastructure, guys, from your point of view? Anyone?
Operating system and underlying hardware.
Operating system and underlying hardware. Okay.
It's network hardware OS servers.
Network hardware, OS servers. So yeah, when we talk about infrastructure, like first we need to understand the physical locality of this, like where is infrastructure located. We call this as a data center, guys. Okay, so data center. So guys, those who are already aware, please bear with me. Those who are new, uh, okay, just try to understand. So initially, this is what we'll be discussing to make sure like everybody is again on the same page to understand what we are talking about. So we have a data center. So now data center is nothing but a centralized location where we have the combination of physical servers, storage, where we store our data. Like when we talk about storage, it's all about storage, I mean SAN, NAS and all. Okay, network, and then security. What else do we have, guys? Monitoring, high availability, and fault tolerance. Like these are all the very common entities whenever we talk about data centers, which are located inside your data center, in the sense which where we run our applications and all. But in order for these components to be up and run all the time, what is that we need, guys? What are the external components that we always need? Anyone? power, cooling solutions. Because these servers emit lot of heat and they need a cooling solutions round the clock. And ISPs, service providers, right? And then finally the manpower who can actually take care of it. Both external and internal as well. So this is the kind of environment that we talk when we talk about data centers. That means all of this has to be considered. Okay, so it's not that easy to maintain data centers. These are the things that we have, and maintaining on-prem data centers is always the biggest challenge. So even Amazon, when we talk about this public cloud service providers, we are free from all of these hassles where you don't have to worry about the space where you want to put it. Okay, you don't have to worry about server, storage, network, security, high availability, fault tolerance, and everything. It is all maintained by Amazon, which is AWS. So you are free from all of this. You don't have to worry about physical power supplies. You don't have to worry about physical cooling solutions. You don't have to worry about physical networks, and as well as the persons who are maintaining all of this. All you have to do is that just rent this hardware and then start building your infrastructure. That's it. Okay. So this is how the cloud service providers look like. So now, even let's say, even if you have all of this in located in based out of Hyderabad, let's say your organization is based out of Hyderabad, or some Chennai or Delhi or somewhere, wherever it is, or in India especially, and for some reasons maybe there is some natural calamities or something because of which this is down. What will happen in that case, guys? Maybe there is a shortage of power, there is a shortage of manpower, or the cooling systems are down for some reasons, and it takes time for them to bring them up. So what will happen during those times now?
We'll have outage.
Outage, right? Now how do I overcome that?
Have a DR.
Having a DR, which means if you are maintaining your own data center now, so maintaining your primary site is also your headache. Now setting up of a DR is also your headache now, right? Isn't it? You're exhausted of investing money here, but now again you still have to maintain a DR, which is again a kind of replica of your existing data centers where you're investing money. So when DR can be used, if it can be used or also, no one is sure, but we still have to set that up to build trust with your client. So this is where organizations are spending millions and billions of dollars to do all of this setup. Now with cloud, they are free from all of this because of the kind of setup these cloud service providers are giving us. Understood, guys? The back end scope of how this AWS infrastructure is going to look like. Okay, so now let's look into it. So Amazon's infrastructure is divided into three major components: uh, regions, availability zones, and edge locations. Okay, so regions, there are multiple regions. In each region, there are multiple edge locations, and edge locations are kind of cache sites that where the end users are going to access the services. Okay, we'll look into each of these things. Now, if you see here, region, AWS region is a physical location spread across globe to host your data to reduce latency. Why is this, guys? Like, just to name few, Amazon has around maybe 18 plus. I'm not sure about the actual. There are around 22 and 23, but 18 is for sure. Like there are 18 plus regions available across the globe. Why do you think these many regions we need? Like our Amazon is setting up these many regions, and the number is still increasing, by the way. What is the purpose, guys? What is the purpose of having so many regions, by the way?
Uh, High availability, basically.
High
Sorry,
availability.
I mean, like, in case of disaster recovery, right?
Hmm.
They should have at different places. Sorry, to avoid the latency, basically.
Avoid the
Latency.
latency. Okay.
Network
True.
traffic.
Latency also falls under that. Yep. Network traffic.
For the load sharing,
Load sharing. Can be. It depends on how we are actually configuring it. But yes, that also could be a reason.
or
Anything
maybe to
else?
reduce the number of hops,
To reach the.
maybe to reduce the number of hops on the internet to reach to the data center, to the server.
So that all falls back to the same point, right? Reduce latency.
Yes.
Yep. Okay. So yes, whatever you said is absolutely true and valid, guys. One is to have the main point is to have or reduce latency. Let us see how. What does that mean, by the way? Imagine, you know, you all know, like I know I'm a trainer and I have my own tutorial. Let's say, suppose where online tutorial, just like YouTube, like where you can subscribe to my channel and then you should be able to view the videos. But initially when I started, I started this from maybe India region, and things were working pretty fine. Like people are able to access my videos and they're able to view it, look into it, and then they're able to access it. All worked well. But now gradually I started getting subscriptions from across the globe. There are people accessing from US, there are people accessing from Australia, there are people accessing from German, right? In this case, what do you think will happen? Like when people are accessing from all the way from US and then India, and the response goes back, there will be a delay in the response, isn't it? This is what we call latency. Okay, to reduce that, what is the solution that I have now here, guys?
We can we can have one more data center near it. I mean, by
Yeah,
replicating the data.
true. That's one scenario. The other scenario is like, let's not talk about the whole regions. Okay, so I have my client, there is a US based client. Okay, and now they're expanding their business and they want to set up their infrastructure even in India as well. Now in this case, like within the India region, people are connecting from all the way from India to US. There will be also latency. So in this case, the only thing that I have is that either I have to put one data center in US. I mean, I need to use one data center in US and another data center in India and put my infrastructure, right? So that India people will connect to the Indian site and US people will connect to the US site. This is one reason, like where you can have your this thing. And talking about disaster recovery, like this is also one of the reason why we have multiple regions. You are already set up your infrastructure in India. Like in India, we have it in Mumbai. And things are running pretty fine here. But what if for some reason, see, what I always say is that our IT works on the conditions always what if you could answer this to your client, then your infrastructure is robust. Like what if this region goes down? What is the solution that we have, guys? So we need to make our infrastructure readily available in other region. The nearest region that we have is Singapore. So now that's where we as an architect, we educate our clients saying that, hey, even if your Indian side Mumbai is down, we have a contingency plan where we have a Singapore which is available. So the moment it goes down, within no time, Singapore infrastructure would be up, and your client should be happy. Got it? So it can also be used as a DR. So all of this is one reason. There is also one more reason, guys. Like AWS is an US based company, and now they are available, or their existence is worldwide, and they wherever they go, they cannot just impose the US standards, right? So when they are in India, they are supposed to follow the Indian standards. I mean, India has their own standards, by the way. When they are in Europe, they have to follow the Europe standards. When they are in Africa, vice versa. They're in Russia, they used to follow the same thing. When they're in Korea, they used to follow the same thing. Otherwise, they won't be able to run the business. That means whenever they are setting up their data centers in India, they are supposed to follow the Indian standards for maintaining the data and all. So that's where there is a GDPR regulation available for Europe, and that's how it is done. So the other advantage of having this region spread across the globe is that Amazon can comply with the local government agency policies, which will help them in running their business smoothly. Understood? But the main reason is to have multiple regions, and moreover available to more number of clients across the globe. That's also one of the reasons. And Amazon AWS region is a physical location spread across globe to host your data to reduce latency. In each region, there will be at least 2 availability zones for fault tolerant. So guys, region is just a kind of location, physical location. But location is not what I need, right? We just discussed before we started. So for an application to run, what is that we need? What do we need for running an application, guys?
Infrastructure.
Infrastructure. Exactly. Now, when we say infrastructure, just narrowing it down, we need an operating system, right? We need some server which has a hardware, RAM, CPU, network, and disk. Now, I cannot just run this on a location, right? Location is like Mumbai is a location, Singapore is a location. But in order for my application to run, I need infrastructure. Now, where am I going to get this infrastructure from? That infrastructure is coming from the availability zone. So in every region, there are minimum 2 availability zones. There could be 3A as well, or 3 to 6. In between these numbers, it could be anything. Now, we just talked about multiple regions. Okay, like they said, there are 18 plus regions. Now, in every region, there are 2 availability zones: availability zone 1, availability zone 2. Now, each availability zone can be considered as a data center. Data center 1, data center 2. Why 2, guys? Why do you think they have 2 within one single region?
The fault tolerant and HA.
High availability and fault tolerance. Exactly. That's the whole point here. That means at any point of time, if one of the availability zone goes down, they still have the other up and running. But tell me, and the distance between them and where are they located, how could Amazon maintain in such a way that failure of one availability zone will not impact the service in other availability zone, guys? How would have they done this?
Replicating the data.
Replicating the data. Okay. Not
Replicating the
really.
data to different regions.
Not really.
Syncing.
No, I'm talking. Yes, I got where you're going now. So let's understand the physical aspects of it before we talk about the data replications and all. Like, how could Amazon do that? Like, failure of one availability zone is not impacting. Like, how would have the setup been?
It's
Like
usually based on the physical location. Like
Physical
if I choose Bangalore, first thing is it is free from tsunami or any of the things related to the sea.
uh,
That's one kind of.
I,
So
I I feel
no,
by taking care of redundancy in every aspect from power, especially from
yes,
the power to every
exactly.
aspect.
Yep. So guys, see, the main purpose of me asking this is to make you comfortable in asking questions. Okay. See, these are initial sessions. The more you interact, the more comfortable you'll become with me, and vice versa. So that going forward sessions will be smoother. Okay. Feel free to answer questions. Okay. Just try, give it a try. Okay. And like SKN, I don't know your name. I see your SKN, but yes. So when I'm talking about the redundancy here, or from the physical aspects, yes, the power supply, the sources of power supply, it might be coming from source 1, this might be working on source 2. Network I'm getting from source 1, here the network will come from source 2. Power solutions are coming from, like, cooling solutions are coming from source 1, here the cooling solution would come from source 2. So at any point of time, any of the source 1 goes down, because of which the availability zone is down, you don't have to worry, because there is another availability zone up and running, and high chances that source 1 fails and simultaneously source 2 also will fail. Got it? So that is how they maintain from the physical servers or physical conditions aspect, like network storage, and all of this. So they always rely on two different entities, and if one goes down, they still have the other up and running. Understood? So before we get deep into that, like how things work and understand better, let us first understand the regions things. So AWS is made up of regions, which are grouping of independently separated data centers in a specific region known as availability zones. In other words, so in simple terms, guys, when let's say you travel a lot, and one of your friend calls you and says that, hey, where are you? And you say, like, in case, right, you travel countries, you would say, yeah, I'm in US, or I'm in India, right, I'm in Australia. And but where in India do you stay? When that goes very deep into it, and actually I want to know your physical location, I know things are like, hey, I'm in India, I'm in Hyderabad, or maybe I'm in some, Banjara Hills or Begumpet, or where do I'm see the physical location is somewhere in my home, isn't it? But when we talk about things, or when we are talking to someone, we just say that, hey, I'm in India or I'm in Hyderabad. But that's what region is. So region represents your geographic location where you stay. But in order for the data to run, or in order for the data to be stored or application to run, we need physical components such as storage, network, and all. And those are coming from the availability zones, guys. That is where your physical data resides. So region is just for us to identify, oh, okay, my data is in Asia Pacific, my data is in US, or US East or West, or Central, or maybe my data is running in Europe East West, like that. But the physical existence of your data is running on the inside your availability zone. Availability of regions allows the architect to design applications to conform to specific laws and regulations per specific parts of the world. Like, we all know, right? There are two different standards which always you get to see, like Europe standards and Indian standards. So we cannot mix them both. US cannot impose standards on US things, and Europe cannot, I mean, US cannot impose standards on Europe. They have to follow, by the way. That's it. So that's one of the main reason why we have so many regions. And when viewing a region in the console, you will only view resources in one region at a time, but they will be across all the ASIS within the region. So we have a console where you get to see all the regions that we have. Okay. And you will be able to view only one region at any point of time, and that specific infrastructure. So this is how the spread. Uh, so Amazon is growing very faster, guys, and so this changes. Okay, every time you look into this picture, this changes. This is the old one, by the way, but you will have some idea of what it is and all. And you see these orange circles inside that there are numbers. So the orange circles that you see are well established regions, by the way. They are well established regions, and the blue one that you see are the coming up regions. And inside them, the numbers that you see are the availability zone. See, Mumbai has 2 availability zones. Now I think it is 3, by the way. So Australia, Sydney, 3. Like we have all of this Seoul, US East, West. Okay, and these are something like a different thing like Europe, German things and all. So these are the numbers, but if you see, there is only one region which is having 6 availability zones, which is North Virginia. Earlier it was 2, guys, but now Amazon is making this number increase to 3. Okay, they're normalizing it to 3, by the way, but minimum 2 will always be there in every region. So you might use like 2 regions, like you can use Singapore or you can use Mumbai as both active sites, or like if you're using US East as a primary data centers, and you can use US West as a backup data center. If that goes down, you still have this running. But hardly, guys, right from the day one that they set up this infrastructure, the failure of these regions has never happened. Okay, it is very high chances, very rare that there will be a failure. Okay, so you don't have to worry about that. But still, when we are designing things, you should consider failing as a kind of entity for you to design your infrastructure. Any questions here, guys, so far? Anyone?
Do we have to set up our applications within the same region? The 2 availability domains. Let's call it Mumbai, okay? So
Mhm.
how do I design my application to be able to have a high availability and fault tolerant? Can I go over from one availability zone in Mumbai to Singapore for my high availability or fault tolerance, or it has to be within the region?
That's a pure business use case, right? You have the freedom of choosing whatever you want. If you want, you can spread your application across all the regions. It's up to you.
Okay.
Okay, it's all about how you want your application to be available to you. And but from the Amazon perspective, you are free to choose any region. There are no restrictions on that.
Okay.
Got it? If your application demands that kind of setup, yes, you're free to do that, and we can achieve that too. Not a problem.
Okay. Thanks.
Yep.
Yeah,
Anything
one more
else?
question. The OS and the hardware, underlying hardware storage system, everything is same across the data center, or it will be different?
Uh, it's the same. Like Amazon tries to maintain the same hardware across the regions. It is the same.
Okay.
Like you have the choices of choosing which operating systems you want, what kind of hardware that you're looking for. These are your own choices, but they are consistent across all the regions.
Okay.
Yep. Something else, guys? Okay. And talking about availability zones. So availability zones work together in a region to make up a collection of your AWS resources. So the availability zones are nothing but collection of your server, storage, network, disk. Okay. Like I said, where your physical entities run, by the way. And properly designed application will utilize multiple availability zones for fault tolerance and failures. So this is important. Like someone has just asked the question, right? How many can I use? It's up to you, the pure business case, depending on the business use cases. But just to make you understand, let's take this as a region. The red box that you see is a region. And let me choose yellow as an availability zone. And inside this, I'll take green as my application, a web app. Okay. This is how a typical infrastructure look like. So we have a regions, and inside the region we have availability zones. Let's say availability zone 1A and availability zone 1B. And inside this, I have created one virtual machine VM, and inside this I am running my applications. So there are end users now, and people are accessing these applications via the browser, and they're hitting onto this application. So far, everything is working absolutely fine. Now, there is some problem with the operating system, guys. Some service, maybe the service is down. We all come across this, right? As system administrators, and developer says that, hey, I was able to access the server just like a half an hour before, but now when I'm trying to access it, it is giving page not found. So what are we going to do in that case, guys? What do we do?
Check the services.
Look at the services, like you do a traditional troubleshooting mechanism, right? You get into it, you see services up or not, why it is not accessing, is there any changes that we did, you do it. Okay, that's fine. And you fixed it, things are working fine. Okay, all good. And he is happy, we are happy. But for some reasons, the availability zone is down now. What will happen in this case?
We'll have to change the connection. We have to use the other available zone.
We have to
Use the another available zone.
use the another availability zone. But this application, whatever the data is available here within the availability zone 1A,
Outage.
it's an outage, right?
Yep.
Now, how do I overcome this now? So I just give you a problem statement now. Using one applications running on one availability zone. This is the problem. Yes, it's an outage. There is nothing that you can do, nothing I can do after failure. If there is anything that I have to do, I should have done before the failure, right?
Yeah,
I
so
should have predicted
basically,
failure, and then I would have planned my design, my infrastructure. Now tell me.
yeah, sorry. So I think before we have two available zone, we have to replicate the same details in the other applicable available zone as well, so that we can access that in case of any failures.
So usually, guys, generally, let's not talk about AWS now. For those who are not aware, this will help you understand this. Let's say I have a standalone server, okay, and where I have installed my web application. Things are working fine. People are able to access it, and they're able to get their websites up and running, all good. But what happens if this fails? I'm not talking about AWS, by the way. I'm just talking about general scenario. I'm talking about a physical server, a standalone physical server.
Outage.
It's outage, right? And how did we overcome a physical server outages back then?
Have a DR.
Yeah.
IDR, like we would have one more server, right?
Load balancer.
We would have one more server. Maybe let's not talk about load balancer also. Okay, I'm just giving you a kind of step-by-step approaches for better understanding. So we have an active server and we have second one passive server. So the concept is like whenever active server is down, passive server will take over. At least there might be some glitch in accessing it, but still things are okay. They are able to access it and fine. This was a scenario. But now there are more number of requests coming up on the server and it is not able to take up the load. In that case, do you think active passive setup will work for me? Not really. I should go with what?
Active.
Active active. When it is active active, do you think will I be sharing the individual IP addresses of the servers? That doesn't look good. So I will have one common entry point, which is what?
Load balance.
Load balancer. Now I will share the details of my load balancer. People will reach out to my load balancer. From there, things will hit onto the physical servers. But now the setup is not this, right? Let me escape and let me get a blank page. Now setup is not running on a physical server. Now what is the setup? Where is the setup actually running? It is all virtualized. You aware of virtualization, guys? No worries if
Yeah.
you're not aware. We'll talk about it. So virtualization is like, why do I have to dedicate a complete physical server just to run one simple web app? Right? Maybe my server is a very robust server, maybe 16 GB server or 16 GB RAM or 32 GB RAM with 8 core processors or 10 core processors. So I'm not utilizing my resources to fullest if I'm running one application. Like our own laptops is the best example, right? So now we are buying laptops with 12 GB memory, 16 GB memory, but how much of the memory am I using at any point of time? Hardly 20-30%. But we bought a server with 16 GB where you pay it like almost like thrice of what you are actually using, and you're not using it. So even organizations thought that, and they came out with a concept called virtualization. So with virtualization, the concept is like you have the physical server hardware, you install the hypervisor, which is the virtualization software. Okay, we'll get into the details of what is what, but try to understand the concept of availability here. And I have my application running. So this application is nothing but virtual machine. Now let me put the same physical analogy here, like whatever we discussed. Now the initially I talked about active and passive. Now what will happen if active goes down, guys?
Passive will become active.
Passive will become active. Fine. And what happens if this physical server goes down now?
Both the VMs will go down.
Both the VMs will go down. Now in that case, is there any purpose that of having me active passive, right? It's a single point of failure, isn't it?
Yeah, that's correct.
Now how do I overcome the single point of failures?
So basically, you should maintain another copy
Yeah.
physical.
So have one more server in place, hardware, hypervisor, and run the second one. Like active one is running here, passive one is running here. Now do I have availability? So if
Yes.
active goes down, you don't have to worry. There is a passive running. even if the physical server where your active is running, you still don't have to worry because your passive is running on the other node. Okay. Now, if you look into the physical entities now, let's say they both are running on the same rack. You know rack, right?
Yeah.
Rack is nothing but a location where you put your servers. Like we place them step by step, and each rack has a power supply. Now, what if the failure is not with the servers, but what if the failure is with the rack itself? In that case, do you have the availability?
No.
No. How do I overcome this?
Have it in different
Set
racks.
set
Different
these two
pods.
servers on the different rack. Like you are getting the point, right? This is how
Yes.
the data centers are maintained. Now, in this case, I have availability at my VM level. I have availability at my physical server level. I also have the available at my physical rack levels. In our case, they are not racks, they are availability zones now. Got my point? That
Yes.
means whenever you are running your applications, spread them across availability zones. But even though they are in two different racks, the communication between them happens without any delay. As end user, they will never know that they are running on the two different racks and all. But as an infrastructure admins or architects, we design this kind of solutions to overcome failures, single point of failures. So this is the kind of settings that we do when we are maintaining the physical infrastructure, guys. So it's the same thing that Amazon does, but they do it in a different way. They call it different availability zone. So when I'm talking about my applications, active is running on 1A, passive will be running on the other availability zone, so that at any point of time, if there is any failure at the OS level, you still don't have to worry. There is the secondary VM running on the other node. If there is any failure on the availability zone itself, you don't have to worry. Still, there is another availability zone. Got it? This is how we do it. So Amazon always recommends that we scatter our infrastructure across availability zones for high availability and fault tolerance. Is that clear?
Shiva, I have one question.
Go ahead, please.
Yeah, here when you say this physical server example, how often we use the second server? Isn't it wastage of resources?
That's the reason there is no concept of physical servers now. It's gone. Everything that we are doing is a virtualized environment only.
You mean to say in AWS we don't have two servers physically?
See, it's a virtualization concept that I'm talking about. Physical server has to be there, but they are virtualized, by the way. And we won't be running one dedicated applications on one dedicated physical server. We virtualize it, and based on the resources that you have, one physical server can accommodate hundreds of virtual machines, depending on the infrastructure, the size of the physical hardware.
Shiva, where is the load balancer placed here? Is it in the availability zone 1 or 2?
So see, when we talk about the services, there are services which are bound to availability zones. There are services which are bound to regions. Okay. So when we talk about availability, I mean load balancers, it is not specific to a region, by the way. They are available inside a VPC. They are common for both the availability zones. Or if you have 4 availability zones, one load balancer is common for all the 4 availability zones. It is above availability zone concept.
But
Okay.
is there any redundancy for the load balancers if that goes down?
That the chances of that going down is that when the entire region goes down, then only the load balancers are down.
Okay.
Okay, they are maintained by Amazon. The concept is like if the if you take about the probability that when will the load balancer be down, the load balancer will be down only when the entire region is down. That's it. Otherwise, there is no fail because they're software. They're not physical components. They're softwares, and their high availability is all maintained by Amazon itself.
What's the average distance between each availability zone? Average within a region.
Within kilometers.
Okay.
See,
Like
region is
100
Mumbai.
So,
Region is
kilometer.
Mumbai. Okay, let's say example. Region is Mumbai,
Mm-hmm.
and maybe one availability zone might be to maybe East Mumbai and other is to West Mumbai.
The availability zone is one data center or multiple data centers?
One availability zone can be combination of multiple data centers.
Okay.
Any more questions?
So the more redundancy we ask, the more the uh, pay as a service cost will increase, right?
Absolutely, yes. So
Okay.
see, if one server is costing you $2, two servers will cost you $4. Okay.
Okay,
Availability
we can go ahead.
zones, yep, work together in a region to make up collection of AWS resources. A properly designed applications will utilize multiple availability zones for fault tolerance and failures. Availability zones have direct low latency connection between each availability zone in a region, but they are completely isolated from each other. Like one availability zone, for us, it's an availability zone, guys. We call it availability zones, but depending on the requirement of resource utilizations, depending on the client base, in the backend, a couple of data centers can be combined to create one availability zones. But as end users, as a clients, we never know how many data centers are available in the backend to create one availability zone. Okay. So edge locations, I'll stop here, guys. We can discuss this edge location tomorrow because we are on top of our like 7. Since it is the first day, even I don't want to overburden with you the concepts. We'll talk about the CDN edge locations tomorrow. Any questions, guys?
I have one question. Like we have multiple, I mean, data of multiple customers located in, I mean, stored in only one availability zones or multiple availability zones in the region. So in that case, if will there be any issues with between customers' data, like privacy issues and security issues?
Yeah, that's a very good question. But thing is, we have those segregations. Like we both, like let's say you and me are two different clients using Amazon. Let's say we are using same region, Mumbai region. So there is no chances that we both can talk to each other until unless we know what is your infrastructure and you tell me what is, or you understand what is my infrastructure. Otherwise, by default, no two different clients will have access to our data, their data. There is no communication at all. We are going to build a complete network isolation. There is by default network isolation is available where that won't happen. Got it? We create a VPCs which are completely isolated from each other. So no two VPCs can talk to each other by default.
Okay,
And
thank
apart
you.
from that, we have encryptions, we have security things, we have firewalls in place where you can restrict the access. All of this adds an extra weightage for security. Okay. Any more questions, guys? Okay. If no questions, maybe we can stop for today, and we'll meet tomorrow to discuss on edge locations, and I'll walk you through some websites where you can see how this global existence of this network is available and all. Okay.
Thanks.
Yeah, thank you, Shiva.
Yep. So thank you guys. Have a good day and see you all tomorrow.
Thanks, Shiva. Bye.
Yep.
Thank you.
Thank you.
Thank you all.